So today I am being asked to look at the following exercise. So the question reads, the elevation of a cone and the development of a label are shown in figure 115, which is here. So draw the elevation and plan of the cone when the label is in position. So from reading that amount of it, I suppose I can figure out that it's actually an envelopment question. So I suppose have to develop the cone, add the sticker, and redevelop or put the cone back together. So I suppose the first thing I can do is I'll have to draw a plan and an elevation. So in this instance I've pre-prepared this much. I have in place, I have a plan and elevation here. I have divided my the plan into the 12 equal sections. This is in order to develop the cone itself, and then here I have the sections obviously also taken up into elevation. I suppose there's two methods of doing this. I could draw the sticker first and build the elevation of the cone around it, or in this instance I'm actually going to draw the development of the cone and then add the sticker and then redevelop it. So before we can start, in order to develop the cone itself, we'll need a true length line. So we'll need to know the exact length of the generators. So one giveaway here is, well, we've two extreme generators here, which in fact are also true length lines. We have the line 9 here and we have line 3 also. So both these generators are in fact, they're extreme generators, as they're extreme generators of the cone itself, and they're in fact they're true length lines as they appear horizontal in the plan view. So by doing so, I can then take these as so, and we'll take them across here, and from here I can swing my arm like so. So I'm going to actually draw my first generator as a vertical one. So this generator will be directly 90 degrees, and we'll call that, based on our drawing, we shall call that line 0. So in order to get the rest of our generators, we will have to take our distances, so from 0 to 1, like so. And in this case, each generator should be exactly the same. Yeah, so this will continue for the next 12, so it'll be 6 either side of it. 3, 4, 5, 6. And then I can actually take back a number of these points to the vertex of the cone, like so. And this is where labeling will come important, so we can relate. So we have 0 here, which is 0, and then we have 1, 2 and 3. So then I can carry around 0, 1, 2, 3, and so on and so forth. So I carry that process around until I have a fully developed cone, and I've also got this pre-prepared, which is just to get things moving a bit quicker. So in this case you can see that I have the cone fully developed, like so. Right, now this is where I begin to actually add the sticker itself. So there's one important point that I've been given. If we look back here, we're given the point P here, and we know that point P is also here. So in order to develop the cone itself, or to add the sticker to the development, we'll have to find point P. So point P in plan over here is down 40 from the top, which we have here, but in an essence it's on line 06, but I cannot just measure from 40 here and mark it there, because as you can see, this is not a true length line, so this does not show the true distance from line P down to from the vertex to line P. So in order to do this, we'll have to take line P across until it hits the extreme generator here, just line 3, and then take my compass again, take this distance like so. So it's very important that we're always working from our extreme generator down to so. So where originally point P, if I had to measure it straight, would have been there, in fact it's here. So if I were to develop out that, I would be very far wrong if I did not carry my points across the extreme generators. So from here I can draw it in vaguely here. So I can take my line across, and on that line then I can begin to develop my cone, or the sticker of the cone. So in order to continue that then, I simply take it down. So I score the entire markings of this, so I have to come down 16, and obviously 16 to the bottom, 100 wide, and then swing the arc. And in fact, just again to speed the process up and keep it going, we have all the measurements necessary there to actually develop the entire thing. So I can just actually go ahead and move on to the next stage of it, which is we have our developed cone with the sticker in place like so. So now we have the developed cone with our sticker in place, and we have point P in place. So whilst we're here on the topic of marking letters and labelling, I'm going to mark every point where the sticker crosses the generator. So we have one here, one here, one here, one here, one here, here. And we also have two important points too. We have two turning points in here which you'll also need to find, which is one here and there, and here and there. So what we'll do is we'll label these. We'll start here, A and B. So we'll make these letters and numbers over here just to distinguish the generators from the points. C, so we'll have D here, E, F, G, H, I, J. O. So we already have a P, so we'll go O, we'll skip it to Q and R here. So now we have all our points in place. We now have to take them across into our elevation. So in order to do this, we will actually begin, we'll for the meantime we'll forget about points D and C, just so we can develop the points that we know where we are. So we'll take, for instance, we'll take point C for us first off. So we have point C here. So we know that point C is this distance from the vertex on line 3. But remember, well, in this instance actually we can take it straight on to point 3, because point 3 is in fact one of our extreme generators. So we have one point here, so that's point C is there. And then let's take, for instance, so one that's not an extreme generator, so we'll go A. So we have point B, so point B. So we cannot swing point B. Point B is on line 2. It's not possible just to take it like so, because line 2 in this instance is not an extreme generator. It'll be fairly close as they're in line, but point B, the first idea is take it onto an extreme generator, and then using our T-square, take it straight across to there, and now we have point B. And we will do the same with point A here, like so, take it across till it has the extreme generator, and then across as if the point was here and the cone was rolled around into place. We now have point A here. So we follow the same steps with each one of these, and we'll end up with something along the lines of this. So we follow the same process with each of the known ones. So in this instance, well, I should have probably listed this here now. In this instance, we have P here, and then we have the rest of our points, which have all been taken across, and so we now have a pattern like so. So it's just a case of we can mark these in, because these are all visible marks. Mark all of these in, like so. It's just we've skipped it on. We've done it with 3 of the points, and I suppose they're all of these follow the same routine. So it's just a case of get your distance from the vertex to the point you want, take it down, score it onto your true length line, and then roll it across into place. So what we now have is we have the basis. We've developed what we can see of the stick here at the minute. Right. So what we need to develop now is what we can't see. So this is a little bit more trickier, but it's just a case of joining up the points through it and down to the bottom, and the same here. So from the vertex through the point beneath and down to the bottom. So what we now know is that we'll call this X, and we'll call this Y. So we know that this point here is on X and this one is on Y. So in order now to find X and Y in our drawings, we will take our compass and we'll score the following. So we know that X is this distance from here to here, from line 3 to 4. So I go from 3 to 4 now, and I score a mark here. And now I can join it back to the vertex, like so. And as the entire thing is symmetrical, I suppose I can just take it straight across here. So I now have it in both plan and elevation. And the same then goes for the second one. So we'll probably go from 4 to 3 because the distance is a bit greater. So from 4 to 3, like so, score the line. From 4 then back to 3, like so. And then we can take this across here. Again, using our T-square, we can take the other lines across as well. So now we have X and Y, so we'll call this X1 and Y1. We'll call this, in this instance of 3, we have Y1 here and we have X1 here. Right. So then it's simply a case of taking these lines up into plan, or from plan up into elevation. So from our plan then up into elevation, like so. We now have 2 new lines, like so. They seem to be very close together now. We join them back to the vertex, like so, and the same in this instance. And again, just like before, we take our distances, so from here down to here, So this is line x1. So x1 is here nearest to here. Roll onto here. And we take it straight across to line x1. Point here. So as we know, this is obviously going to be hidden. So x1's the highest, so we'll find y1, 2, 1 are here. So we'll take y1 up as well. So we have y1 here. So point. Scroll it down. On here. Take it across to line y1. So in this instance we can now join up, but what we got to remember is this is actually a hidden detail. So from here to here is hidden, and then back round to here, and then just that little bit there. And as it says, with that being symmetrical, it's just simply a case of doing the exact same on the other side. But we haven't got, I suppose, just to fly things on, there's no point in really worrying too much about that. It's simply just a case of doing the exact same, so from that side onto the other side. So we're going to now worry about, as the question read, we now have to show the development and elevation and plan of the cone when the label's in position. So in order to do that, what we do is we take our points. Then this one, I'm going to take the points this way because there's a lot of points can get messy over there. So if I take this point across here, let's take it onto our extreme generators. Take it down onto the extreme generator again, and then using our compass we roll it back into place. So in this instance we had point was on line 11 and 7, so there's 1 point there. Same goes for point here. Take it down onto our extreme generator from line 10, and we roll into place. And once more, we'll say we'll take one, final one here, onto the extreme generator. This point's on line 0. We take it back down onto our extreme generator, like so. It's a bit low. No, similar enough, yeah. Again, roll it into place. So what we do then is we continue that with each of our lines. We'll end up with all our points somewhere along the lines of this. So we'll have each of the lines developed as shown. And then it's just a case of here, it's just a case of joining the dots really. When you've each of your points, just take each point down, across. You can do it a bit tighter than that, but just for showing it, for the sake of showing it, that'll give you your final piece. So the important thing to remember is, as I says, this is how it looked in this, in our on this side, and as I says, it's just a case of flipping the rows. You can see this detail behind is hidden, and the main thing to remember is that when transferring points, we've always got to transfer through a point or a true length line. So in this sense, we had true length line. We had 0.9, we had 0.3. So what we've done was we took the points across, down, and rolled them back into place was really what we've done. So that shows you the completed article. We have the question again, just to relate back to it quickly. So it says, draw the elevation and plan of the cone when the label is in position. So here we have the front elevation looking in, so we can see the label here covering the front. We can see the hidden detail as comes around the back, and then in plan then we can see how the label would look fully assembled. So other than that, I think that's about it. Drawing complete.